Now that we've found those two trig limits, let's use them to help us find the derivative of sine of x. Since we don't have any rules, we're going to have to go back to our first principles with the definition of a derivative. So we have to take the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's go ahead and replace f of x with sine of x. So we get the limit as h approaches 0 of sine of x plus h minus sine of x all over h. For the next part, we need to use the trig identity. We have to use the sum of two angles identically. So let's recall what that is. This tells us that sine of a plus b is equal to sine of a times cos of b plus sine of b times cos of a. So let's go ahead and replace sine of x plus h using this identity. So we get the limit as h approaches 0 of sine of x times cos of h plus sine of h times cos of x minus sine of x all over h. So now I'm going to regroup the fraction so I have the sine of x's together and the sine of h in its own fraction. So I have the limit as h approaches 0 of, I'll break brackets, sine of x cos of h minus sine of x all over h plus sine of h cos of x over h, and close the big brackets. Now let's factor out the sine of x from the first fraction. So we have the limit as h approaches 0 of sine of x times cos of h minus 1 over h plus sine of h cos of x over h. Note that cos of h minus 1 over h is almost identical to the trig limit that we just proved, and sine of h over h is a trig limit that we have proven. So what we need to do is make cos of h minus 1 actually be 1 minus cos of h. We can achieve this by factoring out a negative. So I'm going to do two steps here and bring the limit into both fractions and factor out that negative. So I have the limit as h approaches 0 of negative sine of x times 1 minus cos of h over h plus the limit as h approaches 0 of sine of h cos of x over h. Now the limit is only involving h, so we can take the factors involving x and put them in front of the limit. So I get negative sine of x times the limit as h approaches 0 of 1 minus cos of h over h plus cos of x times the limit as h approaches 0 of sine of h over h. Now this is where the limits that we calculated in the past two videos come into hand. We have negative sine of x times 0 plus cos of x times 1. Multiplying this out, we get a final answer of just cos of x. Therefore, the derivative with respect to x of sine of x is equal to cos of x.